So we'll start with the example of NaCl. Now, as we have discussed NaCl, so two elements are sodium and chlorine. Let us look at the configuration of sodium. This is sodium and this is chlorine. So let us look at the configuration of sodium and chlorine. So sodium is 281, chlorine is 287. So sodium, NaCl. So sodium is 11, atomic number is 11, chlorine is 17, atomic number is 17. See, I have discussed in a previous lecture that please do remember the atomic number of the at least of the first 20 elements. So the electronic configuration is 281, chlorine is 287. Yeah. Now, as discussed before, what does sodium want? What does sodium aspire to be? Sodium aspires to lose this one electron. Why does it aspire to lose this one electron? Because if it loses this one electron, it will become something like neon, which is 28. Yeah, and it will have 8 electrons in the outermost shell. Nearest noble gas is 28, which is neon, so it will become stable. So, what does sodium want? Sodium wants that if it can lose one electron, so minus one electron, its configuration will become 28. But what will happen is this part you need to see seriously, and you should get very clear about what I'm discussing now. When you have sodium atom, which is 11 atomic number, the number of protons is 11. The number of electrons is also 11. So that is why it is neutral. Neutral implies that plus 11 charge, minus 11 charge. So the net charge on a sodium atom is 0. But when it will lose one electron, see, it is losing one electron. The number of protons remains the same, but the number of electrons has decreased by 1. So there will be a net charge on sodium which will be plus. I hope this is clear. And that is how it is written as that Na plus 1. Let me try to explain it again. See, sodium has an electronic configuration of 281. It wants to lose this one electron. If it loses one electron, it will become something like 28. When it becomes 28, it will be stable because now it has 8 electrons in the outermost shell. But what will happen to the charge is that sodium atom is neutrally charged because the number of protons is equal to the number of electrons. Once it loses this electron, once this electron has gone, the number of electrons has decreased, number of protons has remained the same. So basically, on losing this electron, sodium will get a positive charge of plus 1. This is a very important thing to understand. I have taken this example. If you haven't understood, you can rewind the lecture and try to understand this. That when an atom loses one electron, it gets a charge of plus 1. If an atom loses 2 electrons, so let me take an example of say magnesium, because anyways we'll be discussing magnesium also. Look at magnesium. Magnesium 12. So number of protons is 12. Number of electrons is also 12. So magnesium atom would be neutrally charged. But electronic configuration of magnesium is 282. It wants to lose this 2 electron. If it loses this 2 electron, see, the important thing to understand is that protons remains the same, but electron has decreased by 2. So the positive charge has remained the same, but the negative charge has decreased, and that is why you will have a net charge of plus 2. So magnesium, by losing 2 electrons, will become magnesium plus 2. The electronic configuration of magnesium would be 282. The electronic configuration of magnesium plus 2 would be 28. This is a thing that you should be very, very clear about. And something when it, this is what is called an ion. Ion is something which has a charge. And ions which have a positive charge are called cations. Are called cations. Cations. A mnemonic you can use this, you can consider this T to be positive. So this is cation. This is how you can remember. So sodium wants to lose one electron and become Na plus 1. And what does chlorine want? Chlorine electronic configuration is 287. What chlorine wants is, let me rub this. So what does chlorine want? What chlorine wants is that it should get one more electron. Because if we look at the configuration, let us look at chlorine. If it gets one more electron, it will have a configuration of 288, which looks like argon. So that is why if it gets one more, I'll write it here. Let me write it here. So chlorine, if it gets one more electron, like we have done for cations, there is something called anion. Anion is an ion which has a negative charge. Now chlorine, when it gets one electron, it will have, from a neutral entity, it will become entity with -1 charge. Again, if you want to understand the logic, so chlorine has number of protons as 17, number of electrons as 17. When it gains one electron, the number of electrons is 18, but the number of protons remains the same, which is 17. So this is plus, this is minus, and the net charge is -1, which is this -1. Hope this is making sense. So let's rewind and understand what is happening. Na281 wants to lose one electron and become Na positive. Its new electronic configuration would be 28. Chlorine 287. Let me write -1 electron here. Chlorine wants to gain one electron. Gain one electron. It will become chlorine -1. Electronic configuration 288. Now Na is happy, Cl is happy because Na has become Na positive 28. Chlorine has become chlorine negative 288. Both are happy in a way. And another thing which has happened is now Na has become positive charged, chlorine has become negative charged. Positive and negative will attract each other. So they will become this compound which is called NaCl. Here this is +1, -1. Sodium chloride because of the opposite charges. And these kind of compounds which are attracted to each other due to opposite charges, they are called ionic compounds. Ionic compounds. Ionic compounds. There's a second example that we will be taking MgO. Now I won't be going into as much detail as I have done before, but in MgO what will happen is, let me take MgO CaO. MgO CaO I'll take together. MgO CaO. So first thing that you need to understand is the electronic configuration. So Mg, we look at the configuration of magnesium, it is 282. 282. Oxygen, we look at the configuration 26. 26. So again, what does Mg aspire to? Mg aspires to lose 2 electrons, -2 electrons. On losing 2 electrons, number of protons would remain the same, but number of electrons would decrease. That is why it will have a +2 charge. You need to understand, get this very clear. Oxygen wants to gain 2 electrons, and when it gains 2 electrons, it will become O-2. Because now 2 electrons would be added. That is why it will gain 2 electrons. And Mg, when it loses 2 electrons, let me show you here, magnesium, when it loses 2 electrons, When it loses 2 electrons, it becomes like neon. And oxygen, when it gains 2 electrons, it becomes like neon. neon. So again, Mg plus 2, oxygen minus 2, opposite charge attracted to each other, become an ionic compound MgO. Now, another thing that you can understand is because it is plus 2, it is minus 2. So both these charges have cancelled. That is why magnesium oxide will have no charge. NaCl plus 1 minus 1 charge. So net charge would be 0. Let's take example of CaO. CaO. Let me write here. CaO. Electronic configuration 2882. Here 26 wants to lose electron. Becomes Ca plus 2. Electronic configuration 288. Why? Because it has lost 2 electrons. Gain 2 electrons will become O minus 2. Electronic configuration 28. It will become a compound Ca plus 2, oxygen minus 2. So it will become a compound like CaO. Again, plus 2 charge, minus 2 charge, net charge is 0. So calcium oxide has no charge. And the final example that we want to take is lithium fluoride. Lithium fluoride. So lithium 2 1 wants to lose electron, 1 electron. Lithium 2 1 sorry 2 1 wants to lose 1 electron, become lithium plus 1. Fluoride, fluorine 2 7 wants to gain 1 electron, wants to gain 1 electron, wants to lose 1 electron. By gaining 1 electron, it will become F minus 1. So Li plus 1, F minus 1 will become lithium fluoride. So all these are examples of ionic compounds. So you would have understood that these are the ionic compounds. So in ionic compounds, one entity loses electron, the other gains electron, and because the number of electrons gained by one and lost by the other are the same, so the net atom, net compound, net molecule which will form will have zero charge. So that is something that you need to understand very clearly. What you need to understand is that NaCl has no charge, MgO has no charge, CaO has no charge, LiF has no charge. But Na has plus 1 charge, chlorine has minus 1 charge, Mg has plus 2 charge, minus 2 charge, plus 2 charge, minus 2 charge, plus 1 charge, minus 2 charge. Ionic compounds are formed when one of the participating element loses electrons and the other element gains electrons. So that is something that you need to understand about ionic compounds very clearly. Then there is something called uh, covalent compound. But before that, I just want to show you few of the properties of ionic compound. In the second part, we'll do the covalent. In the third part, we'll do the covalent compounds. So ionic, found by the transfer of electrons from metal to non-metal, typically involve metal and a non-metal. Forces involved electrostatic force, very strong electrostatic force. Melting have very high melting and boiling points. Solubility, they are often soluble in water. Electrical conductivity, conduct electricity. Examples NaCl and calcium chloride. If you want to understand about calcium chloride, we can take the example of calcium chloride also. I'll write calcium chloride here and I'll explain how CaCl2 is formed. So Ca2882 forms 288, loses 2 electrons and becomes plus 2, becomes a cation. But if you look at chlorine, chlorine has a configuration of 287, electronic configuration of 287. Each of chlorine atom wants just 1 electron. So it will become Cl negative, electronic configuration 288. But then two such chlorine come together. So 287, another chlorine comes, which accepts one electron, becomes Cl negative 288. Now this one has lost two electrons. One chlorine has gained one electron. Another chlorine has gained one electron. So what has happened is Ca2 positive, and there are two chlorine ions which are formed, and each of the chlorine ion has -1 charge. And in terms of chemistry, this is written as CaCl2. So how do we read CaCl2? So CaCl2, one calcium ion, basically a cation, which has +2 charge. Cl2, two chloride ions, two chloride ions. Each of the ion has -1 charge. And in total CaCl2, because Ca has +2 charge and chloride has a -2 charge, so the +2 and -2 cancel each other. That is why CaCl2 has no charge. So we have taken the example of ionic compounds in this part. These are the examples we took: NaCl, MgO, CaO, LiF, CaCl2. In the third part, we will do the covalent. Ionic compounds, one of the entities will lose electrons, other entity will gain electrons. That is what you need to understand. What you need to understand very clearly is what are anions, what are cations. I have told you the mnemonic that you can do is cations, this T can be written as positive, anions, this N can be considered to be negative. So anions are negative, cations are positive. I hope this is clear, and now we will go to the covalent compounds. And it is important to, this is an important uh, comparison of ionic and covalent compounds. This is a difference that you should remember. You should remember few examples of ionic compounds, few examples of covalent compounds. You should at least remember three properties which differentiate ionic and covalent compounds. We'll discuss covalent in the next part of this lecture. So I hope you are clear till here.